just like how I can represent a KD tree in this binary search tree looking representation, where I have a binary tree that I'm doing comparisons with respect to x level, like x dimension, y dimension, x dimension, iterating over the dimensions, I can represent the points in my KD tree as partitions of k-dimensional space. So here I have an example KD tree where my points are in two-dimensional space, and I can represent it as partitions of two-dimensional space. So let's take a look at this point, 7, 2. In my KD tree, theoretically, this would split my data points into values that are less than this, less than x equals 7, which would be in the left subtree, or greater than x equals 7, which would be in the right subtree. So I can draw a point at 7, 2. And this is separating x-dimensional space. So x-dimensional space is this dimension. So this is a line that separates x-dimensional space. Things that are less than x equals 7, things that are greater than x equals 7. Now in this level, things that are less than x equals 7, so things that are on the left side of this partition, this is now looking at the y dimension, and it's separating things that are greater than y equals 4 or less than y equals 4. So I can draw this point, 5, 4, and this is a partition of the y dimension. So I'm partitioning this dimension. So this would be a line up to this point because I must be less than 7. So I must be on this side of the line. But now this is a division, a partition of y equals 4. Things that are greater than y equals 4 or things that are less than y equals 4, given that they were less than x equals 7. Here, given that something was less than x equals 7 and it was less than y equals 4, this gives me a partition over the x dimension. So 2, 3. Given that I was less than x equals 7 and less than y equals 4, this gives me a partition over the x dimension. And similarly here, given that I was less than x equals 7, so I'm just going to actually circle this for clarity, less than x equals 7, given that I was greater than y equals 4, so less than x equals 7, greater than y equals 4, for 7 is this point. This is also splitting the x dimension. So it's a partition at the x dimension. Okay. Now let me go to this subtree. So now this is given that I was greater than x equals 7. So given that I'm on this side, this is partitioning in the y dimension. So let me actually maybe circle these ones because I forgot. So given that I'm greater than x equals 7, so I'm on this side, this is creating a partition at 9, 6. That's partitioning y-dimensional space. So it's a partition of y-dimensional space, given that I was greater than x equals 7. So I'm on the right side of x equals 7. This creates a partition at y equals 6. That's done. Now my last point. So given that I'm greater than x equals 7, so I'm on the right side, and I'm less than y equals 6, so I'm below this point, so greater than this, below this, I have the point 8, 1. So 8, 1, which is a division, it's a partition of the x dimension. So I'm partitioning this space there we go. So now I've created all of the k-dimensional, in this case k equals 2, so the two-dimensional partitions based on this KD tree.